Hi everyone. In this video we're going to solve rational inequalities. Starting with our first one, we have x minus 3 over x plus 4 minus x plus 2 over x minus 5 is greater than or equal to 0. And I'm giving you the graph on the right here so you can think about what's going on before you actually do the algebra. Okay, so like the other inequalities we've solved, when I say this is greater than or equal to 0, really I'm saying the function, which I could call like f of x, is greater than or equal to 0. And f of x is kind of like saying y is greater than or equal to 0. So when you're solving this inequality, you're really asking when is this function greater than or equal to 0, which is where y values are greater than or equal to 0, which our y values are greater than or equal to 0 above the x-axis. Okay, so you can kind of see the solution without doing the algebra when you have the graph. Now, our goal is to figure out how do we do the algebra to match our solution. So for a second, I want to refer back to polynomial graphs and their solutions to inequality. So say you had a polynomial graph that looked like this, okay, and I wanted to know where this was greater than or equal to 0. The solutions would be up here. So what we needed to do algebraically was to find the x-intercepts. And the reason for that was the x-intercepts tell us where the graph is transitioning from below the x-axis to above the x-axis. Okay, so that solved our inequality for us. Now, what's different about a polynomial and a rational equation is that a rational equation, while it will have zeros, it'll also have asymptotes. Like you see one here and you see one here. And the thing about an asymptote is the graph can jump from above to below at any asymptote. So like see it's above here and then there's no x-intercept, but whoa, all of a sudden it's below the axis. Okay, then there's an x-intercept here and it's above. And then, whoa, there's an asymptote, and all of a sudden this graph is below the x-axis. So before we only had to look at zeros, because that's the point where it changes from below to above. But now I need to also look at asymptotes as critical values, because at either side of an asymptote, we don't know whether it's below or above the axis, because it can make that jump. Okay, so ultimately, if you have a rational inequality, you still need to find zeros because as you see in this 0 here, it goes from being below to being above. So we need that as a critical value, but we're also going to need asymptotes as a critical value. So like this particular inequality, we should have 3 different critical values because there are 3 places where it could change from below the x-axis to above. Okay, so let's figure out how we do that algebraically now. Keep all of that in mind when we do this. Okay, first and foremost, rational inequality is typically, or rational function is typically like a fraction, but right now we have 2 fractions. So you're going to need to use your skills of rational expressions to combine these into 1 fraction. So let's do that. We need a common denominator because we are subtracting fractions. So this one has an x plus 4, this has an x minus 5. That means this has an x minus 5, or needs one, and this needs an x plus 4. Okay, once we have a common denominator, we can subtract fractions. It's a good review. So our common denominator is x minus 5 times x plus 4. And then we just need to figure out what the numerator looks like. So I'm actually going to go ahead and distribute these. So with that said, you get x squared minus 3x minus 5x plus 15, which I can combine like terms, and that gives me x squared minus 8x plus 15, okay, in the left fraction. Do the same thing here, and I will get x squared plus 4x plus 2x and plus 8. Okay, combine like terms, and don't forget this is being subtracted, and you're subtracting all of this. That means you're going to need parentheses. So I get minus x squared plus 6x plus 8. Okay, and that's greater than or equal to 0. Now I need to kind of simplify this up here, so I'm going to combine my like terms, and if I do that, don't forget to distribute the negative because it's all being subtracted. Okay, that whole fraction. So I get x squared minus x squared. Oh, nice, those cancels out. I have minus 8x minus 6x plus 15 minus 8. So minus 8x minus 6x, negative and a negative, that's going to give me minus 14x. 15 minus 8 will give me positive 7. And now I have 1 fraction that I can look at. Okay, So as we said from the graph here, now that I've got my rational equation, I need to find my critical values. So I need to find vertical asymptotes, zeros, and that's it. Okay, vertical asymptotes are the easiest thing to see right now because that comes from when your denominator equals 0, because that's an undefined value that cannot be on the graph. So one of my vertical asymptotes is x equals 5. One is x equals -4. Okay, those are values I'm going to need to look at to figure out where the graph is above or below the x-axis. Okay, now I need x-intercepts, which come from the numerator. Okay, because in order for our function to equal 0, I'd have to have 0 in the numerator, because it'd be 0 divided by some number, which would give me 0 as an output. Anywho, zeros come from the numerator. So I have -14x plus 7 equals 0. I can solve that. I get -14x equals -7. Okay. And then I get x equals, I'll divide this by -14. So negative divided by negative is positive. 7 over 14 is actually 1/2. Cool. So I have my, let's see, 1, 2, 3 critical values. I'm just going to plot those on a number line. So here's 1, 2, 3, 4, 5. And then I have -4. It's right here. And then 1/2 is about right here. Okay, so let's pretend for a second I did not have this graph. I need to figure out at these different values whether the graph is above the axis or below the x-axis. Okay, so how can I do that? The easiest way is going to be to plug in points. Okay, so I can plug in a point here and figure out, is my output positive or negative? And then I know that this whole branch will be either above or below the x-axis. Okay, then I can repeat that for this interval, and this interval. Okay, so I'm going to pause the video and do that because we don't really need to plug and chug points together. What I'd like you to do is to do that on your own. So here's our function. Plug in maybe like -6. I don't know, -1, maybe 1, maybe 6. You don't have to pick those, but I just chose numbers I thought would be easy. So go ahead and do that on your own. Okay, I hope you paused and did that on your own. I have my sign chart here, and let's interpret what this means. So I wrote down the values I got when I plugged stuff in. I actually decided to plug in 0 instead of -1 because that just made more sense to me, just so you know. Okay, so I plugged in -6, I got a positive number, which means that my y value is positive, which means it's above the x-axis, which if you match that to our graph, it makes sense. Okay, to the left of -5 is -6, and it is in fact above the x-axis. Okay, now I plugged in 0, okay, and at 0, it's negative, which you can see right here. And then once I go and plug in 1, which is over here, it's positive, which demonstrates that this was below and then it was above. Okay, then I plugged in something to the right of 5, which I plugged in 6, and I got a negative number, as you can see here, which is matching that branch that is below the x-axis. Okay, so algebraically, you can just test numbers and figure out what are my outputs. Okay, so these signs represent my y values being positive or negative, which tells me is the inequality greater than 0 or less than 0 here. Now, ultimately, I wanted all the values where this function, if you remember our original problem, where the function was greater than or equal to 0, which means the ones that are above the y-axis. Okay, so my intervals would include this one, and that's it. So anything from -infinity to this value is 5, -5. So -infinity to -5. And then anything from, this was 1/2. Okay, so anything between 1/2 and it just stopped at 5. Okay, so let's just make sure that matches. Got to check my work here. So above the axis from -infinity to 5, and then again above the x-axis from 1/2 to this asymptote at +5. Cool. So your algebra should always match your graph, and you can do it either way. It's kind of cool. I'm going to leave this one for you to try on your own. One thing that is different here is that it's not set equal to 0, which means we can't talk about below or above the x-axis. So think about what you might have to do differently to get the answer. Try it on your own. I will come back with the answer. Okay, here's all my work. I got my fraction on the other side. I did all my fraction subtracting stuff to get this as my final inequality, to which I found the zeros and vertical asymptotes. You can check here. Then I did my little sign chart. I got negative, positive, and this is my final solution written in interval notation. And you can again always check this by sketching a graph, and it should match. Even use Desmos while you're learning. Okay, I'm not going to go through all this, but if you have questions, please bring them to class. And I realized one thing as I was going through this. This says it can be greater than 0, so it can't be equal to 0. So that means the graph can't actually be on the x-axis. So that's why I have parentheses here. But the one above said greater than or equal to 0, which means the values on the x-axis are included. Okay, so technically this point is included because it's greater than or equal to 0. Okay, so think about how I need to change my answer to fix the mistake I made there. I'm going to leave you with that and come with any questions you have. Have a great night.